Hello, welcome back to Daily Dose of DSA. So in the last video, I asked you guys to implement my stack class using just one queue, right? So if you have done it, great. If not, you are going to learn it through this video, okay? So now let's go to whiteboard and see how we can do this question. Okay, now I want to implement these four functionalities of stack using just one queue, right? So first I will draw a queue. So this is my queue. In queue, we push value from the back and we take out values from the front. Okay, let's name this queue main queue. I will also draw a stack just to give you the perspective of how things will work in the stack, and then we will try to implement the same thing using just one queue. Okay, so this is my stack. Let's name it st. Okay, now let's talk about this push function. So if I want to push value in a stack, I will simply push value from the top, right? If I want to push one, I will simply push one to my stack, and now one is my top element. If I want to push two, I will simply push two to my stack, and now two is my top element, right? If I want to push three, now three is my top element. If I want to push four, now four is my top element. Okay. Now I want to implement the same functionality using just a queue, right? So it is simple. We are going to implement it the same way we implemented the push function in the last video. So we will simply push the values on the back of the queue. So now we have pushed one. If I want to push two, I will simply push two from the back. If I want to push three, I will simply push three from the back, and I will simply push four from the back. Okay. So yeah, so we have implemented the push functionality. Let's talk about this Boolean empty functionality. It is also simple. We will simply check our main queue. If our main queue is empty, we will return true. If it is not empty, we will return false. Done. Okay, now let's talk about this pop and top function. In the last video, we implemented both the functions with the help of another queue, a helper queue, right? But in this video, we have to implement it with the help of just one queue. So let's see how we can do that. First, we will see how this pop function works for my stack. So if I'll call this pop function for my stack, this pop function will pop out this topmost value 4 and will also return this 4. Okay, now we will try to implement the same with the help of our main queue. Okay, so if I want to implement this pop function, I need to access the topmost element of my queue, right? And in queue, we can only access that element which is present at the front of my queue. Okay, if that element is not present at the front of my queue, I cannot access it. Simple. Okay, so I want this 4 to be present at the front of my queue. Okay, so for that, what I will do, I will take out this one and I will push it back. I will take out this 2. I will push it back. I will take out this 3 and I will push it back. Now you can see this 4 is my front element, right? If it is my front element, I can access this, right? I can access this 4. So I will take a variable. Sorry, I will create a variable val. I will give this variable value 4. Then I will pop out this 4. And after popping out this 4, I will simply return my val. Done. So this is how you will implement the pop function. Okay, let's see how we can implement the top function. Okay, so this top function, if we talk in terms of stack, this top function will return the topmost value. So this top function will return 3. Okay. Okay, so let's talk in terms of queue. If I want to access this topmost value, simple. I have to make this value my front value, right? So I have to take out this one from my queue and push it back. I have to take out this 2 from my queue and I have to push it back. Now 3 is my front value. I will create a variable, let's say val. I will give this val value 3 and I will take out this 3 from my queue and will push it back. Okay, so now you can see we have this value 3 in a variable, and now we can simply return this variable val. Done. So this is how you will implement the top function. Okay. Okay, yeah. So we have successfully implemented push, pop, top, and empty. Now let's try to code it. Let's try to code it. Okay. So we need a queue, right? We have to implement it with the help of just one queue. So let's create a queue, main queue. In the constructor function, we will do nothing. In the push function, we will simply push value to our main queue, so push x. And in the empty function, we will simply return, if our main queue is empty, we'll return true. If our main queue is not empty, we'll return false, right? So simply return main dot empty. Okay, let's talk about this pop function. And let me also draw the queue here. So this is my queue. Okay, this is my main queue. I have 1, 2, 3, and 4. Okay, if I want to access the last element, which is the topmost element, right? So I have to take out these elements from my queue, right? Okay, let's generalize it. So let's say we have n elements in my queue, and I want to access the lastmost element. It means I have to take out n minus 1 elements from my queue and have to push it back, right? So we will do the same. I will create a variable n, which is equal to main.size minus 1. Okay, I will run a loop n times, and I will simply do one thing. I will take out values from the front and will push it back to my queue. Okay, so main.push what? Main.front. And I will also pop out values from the front. Done. After doing this, my topmost value is my front value. So I will simply store that topmost value, which is my front value, in a variable called val main.front. Okay, and I will pop out that value, main.pop. Done. And at the end, we will simply return val. Okay, we have implemented our pop function. Okay, now I want to implement my top function. So it is almost same as my pop function. So I will copy my code. I will copy my code and paste it here. Now I have to change just one thing. If I want to store that front variable in a variable called val, okay, let's say I've stored that front variable in a variable called val. Now I am popping out that variable, but after popping out that variable, I have to push it back. This is the only change we have to make here. Okay, so I will do main.push val. Done. So we have successfully implemented my stack class using just one queue. Let me run it. Let me also run my code. Let's see. Yeah, it is getting accepted. Let's submit it. Done, right? So let's talk about complexity then. Okay, so our code is working. Let's talk about complexity. Of course, this push function works in O of 1, and this empty function is also works in O of 1, constant time complexity, right? Both these pop and top function works in O of n time complexity. Why? Because let's say our queue stores n elements, right? We are taking out n minus 1 element, so almost n elements, right? So the complexity is O of n for both pop and top functions. And of course, if we talk about space complexity, it doesn't matter if we take 2 queues or 1 queues, the complexity is same. It is O of n. Okay. Yes. If you really like my explanation, please like and comment on this video, and also spread awareness about the design topic, because these type of topics are getting asked in top tech company interviews. So share this video with your friends and your classmates. Okay. And yeah, that's it for this video. And thanks for watching, and keep coding till the next video drops.